We're told in this question that two figures are considered to be different looking if one cannot be rotated to produce the other. For example, this one and this one, we've just rotated it slightly. They're exactly the same. However, the first and the third one, you can see the kite has stayed in the same place, but the triangle has moved. So there's no way I could rotate that to give that. And they're different looking, as the second one and the third one would be as well. So that's what we're going to be investigating. And then we're told we have lots of congruent square tiles. Half of them are painted white and the other half are painted black. And we're going to fit 4 of them together to make a larger square. Let me just bring this question down. Okay, and let's have a go at it. So first of all, we're asked to draw the 2 different looking squares that we can make using 2 white and 2 black tiles. Basically, we have lots of white and lots of black tiles. We have enough to, fill in as many as we want. Okay, it says we can either color the squares or use the letters W and B. That would be slightly quicker, but I'm gonna color them. And so what I could do is I could color these 2 black that are next to each other, and then these 2 would be white. Now hopefully you can see as you rotate this, we're going to get the top right and the bottom right um, would be black, or we could rotate it again. We get the 2 at the bottom would be black, or these 2 would be black. Basically, these 2 next to each other are gonna contain all the possibilities when there's 2 black next to each other, and all that is going to leave is one where they're not next to each other. So this one we can make black, and leave a gap and make this one black. See, actually, this is going to have rotational symmetry of order 2. So it's this will look the same. This is back to the start now. So those are the 2 possibilities. We're then asked how many different looking squares can we make in total. So now we don't have to just have 2 black. So we've dealt with that. 2 black, 2 white, 2 possibilities. Okay, so first up I'm going to look at what if they're all black. And that must be exactly the same as if they're all white, because there's got to be a symmetry to this problem. There's nothing special about black and white. So clearly there's only one possibility of 4 of them being black. And the same over here. So all I've got left to do is look at 3 of them being black and 1 of them being white. And that would be exactly the same as 1 of them being black and 3 of them being white. Okay, as I rotate this, you should be able to see that the white, well, I haven't made it white yet, but the white square is just going to move around. So it's going to be bottom left, then top left, then top right, then bottom right. So actually, there's only one possibility here. And I'm not even going to draw the next one. 1 black, 3 whites must be the same. One possibility. So in total, there's going to be the 4 that we've got here and the 2 that we had before. How many different squares? 2 plus 4 lots of 1, 6 different squares. Nice one. Let's take a look at the next part of the question. We have lots of congruent tiles now in the shape of an equilateral triangle, half of them white, half of them black. And we fit 6 of them together to make a regular hexagon. Here's one I made earlier. How many different looking hexagons can I make using 3 white and 3 black tiles? Okay, let's take a look at this. So we could, again, just like with the square, we can work in a systematic way. We could make them, the three of them, black next to each other. And these are going to be white. And as we rotate this round, you can see that it's just, these three will be black, and then these three. This is the only way that we can draw, make three of them black next to each other. So one possibility like that. Okay, next up, well, we could make two of them black, and then leave a gap, and then one of them black. So now as I rotate it, I'll always have two black, one white, one black, two white. I could even write it maybe as black, black, white, black, white, white. Okay, that's clearly going to be different to this one, which was always, and obviously I can, as I rotate it, I'm kind of moving a different one to the front. I suppose it's maybe better to draw it in a little circle, but I don't know. Drawing a line also is quite useful. So if we look at another one, well, I could make these two black again, but instead of having black, black, white, black, I could have black, black, white, white, black. That's going to be different looking, as you can see here. There's no way I can move these around, like, swap them around, move this one to the front and move this down to give the same as that one. But notice if I move it again, I'm back to getting this one. So those are all the different possibilities where I have two blacks next to each other and then one black away. Hey, are there any more? Well, we've not looked at the scenario where we don't have any of them next to each other. So that one, and then leave a gap, that one, and that one. And that's going to give a new possibility. And as I rotate it, okay, I might end up with that one being black and that one, but they're all going to look the same essentially. So how many different? There are four. Four different hexagons. Okay, I hope you're convinced by that. I've tried to argue it use a systematic method. Finally, how many different looking hexagons can I make in total? Right, well, let's look at 6 black and 0 white. Clearly, there's just going to be one possibility here. I'm not even going to draw it. And because of the symmetry, 0 black and 6 white is going to be also 1. So now let's take a look at 5 of them being black. Well, actually, this is going to be pretty quick as well. Because as we rotate it, we're just going to move around the white one. And there's only going to be one possibility. I'm actually at this point not going to shade them white anymore. If they're yellow, then they're still white. So 5 black, 1 white, 1 possibility, 1 black, 5 white, for the same reason, 1 possibility. That leaves 4 black and 2 white to look at. So now I could have all 4 of them next to each other. That would be one possibility, and I can imagine rotating it around to just get these 2 white ones rotating around with it. Or I could have 3 of them next to each other, and then a gap, and then one here. There's only going to be one way, just like before. I had more than one possibility when it was 3, didn't I? Because I could move it. I could have 2 and then a gap, then 1, or 2 and then 2 gaps and then 1. But here, if I try and make another gap, actually I'll end up back to here. So 3. So now I just need to look at what if I had 2 next to each other and then a gap. Okay, this is going to be another possibility. And then if I move them again, I'd again get the same as the first one. And I can't have I can't just have one in a gap, then one in a gap, then one in a gap because that's not gonna fit. So there's going to be 3 possibilities here. By symmetry, that's going to mean that the 2 black, 4 white one is also going to have 3 possibilities. And so how many different looking hexagons are there? We have 4 from the 3 and 3. And then we've got 1, 1 and 3 double counted. Okay, or you can just add them up. 1 plus 1 plus 1 plus 1 plus 3 plus 3. That's going to be 5 times 2, 10, 14 different looking hexagons. Hey, a nice question, like kind of like an investigation. And you can imagine extending it to, higher order polygons. That might be something to look at. But well done on your efforts.